Alright, welcome to 2.3. Here are some notes and some examples. So, let's begin here. So when we're talking about histograms and percentile ranks, that's really what we're going to be focusing on here. Is we're going to be focusing on histograms and things called bins. So we've done box plots before, and a box plot gives you an idea of the overall distribution of a data set. But in some cases, you might want to see other information and details that a box plot doesn't show. So something called a histogram is a graphical representation of a data set. So we can say a histogram is, let's see if I can get this here. Come on, Hey, there we go. There we go. So a histogram is a graphic, I don't need all capitals here, graphical representation, okay, of a data set with columns to show how the data are distributed. So let's see if I can get this so you can actually read it. So there we go. How data are distributed, okay, across intervals of values. Across intervals of values. Okay, histograms give vivid pictures of distribution features such as clusters of values or gaps in the data. So the columns in the histograms are called bins. Alright, so the bins are the columns. Alright, the bins are the columns of the histograms are the bins, and should not be confused with the bars of a bar graph. Alright, so I've kind of included this graph here. So we're talking about student eye color. This is a bar graph right here. Okay, and the bars of the bar graph indicate categories, meaning what kind of eye color there are. Black, blue, brown, green, hazel. Alright, how many data items either have the same value or a shared characteristic. How many students have brown eyes. The bins of the histogram indicate how many numerical data values fall within a certain interval. So we're looking at student height, we're looking at the interval between 145 and 155. The bins of the histogram indicate how many numerical data values fall within a certain interval. You would use a bar graph to show how many people in your class have various eye colors, but a histogram to show how many people's heights fall within certain intervals. Alright, so the height of each bin shows the frequency or the number of students whose heights fall in that interval. So in this case we have 2 students whose heights are in between 145 and 155. We have 6 students whose heights fall in between 155 and 165. Alright, so that means it could be anywhere in this interval. Alright, the width of each bin represents an interval of 10 centimeters. Boundary values fall in the bin to the right. This bin includes heights h, and the interval 175 is less than or equal to h is less than 185. So if it's equal to 175, it goes in this one. If it's equal to 185, it would go in the next one. So anyone in here could be 165 up to 174.9 repeating, and this one would be 175 and higher. Alright, there you go. So now let's look at this example. So I have an example, I have some data, I have some graphs, and we're going to answer the questions right up here. Alright, so Shativa took a random sample of 50 students who own MP3 players at her high school and asked how many songs they have stored. The 2 graphs were constructed from the data in the following table. So here's the data, we have it all here. Here is graph A, here is graph B. Notice how number of songs is both independent. Number of players is the dependent variable for both of them. So we're representing the exact same data in just 2 different ways. So what is the range of our data? Well, if we look at the table and we look closely, the largest one is, or the smallest one is 765. So that's the minimum. And the maximum is 1013. That's the max. So if we want to find the range, 1013 minus 765, and our range is 248 songs. Alright, if we look at our data, here's 113, there's our max, and 765 is in here somewhere. Alright, so if we can find it, we'd say, oh, okay, there we go. Or we can look at here and say 765 is going to be somewhere between 750 and 800, or between 750 and 760. That looks like we might be going up by a little bit here. So there you go, we have 765. Okay, here's the next question. What is the bin width of each graph? So if I'm going graph A, So we're looking at graph A. We look at what's the bin width. Well, it goes from 750 to 800, 800 to 850. So we know graph A, the bin width is going to be 50 songs. All right, and then if we're looking at graph B, let's look at that one right now. We go 750, 1, 2, 3, 4, 5, 6. Let's see if we can figure out where they are at. 750 would, well, 700 is right there. So we have 1, 2, 3, 4, 5. Okay, so that means every 5 we're going here. So that means the bin width is going to be 10 songs. All right, so each one is going to contain 10 songs. So question C, how do you know if the graph accounts for all 50 values? So how do you know if you account for all 50 values? What we can do is you can actually count. There are 4, the frequency is 4, and then it's 6, and then we have 14, and then it's 18, and we go back to 8, and then you go back down to 2. So if you add all these numbers up, you would get to 50, and similarly if you were to do the same thing for graph B. Okay, so part D, why are the columns shorter in graph B? The bins in graph A hold values up to 5 bins from graph B, right? So because these are so much bigger, we can every 5 bins here is going to be one of these. So that means, of course, these are going to be taller because we're adding all these together. So that's why these are going to be shorter. Which graph is better at showing the overall shape of the distribution, and what is the shape? Well, because we have so many small bins here, it doesn't really give you a good idea of the overall shape of the graph. This one looks a lot better, and what we say this one is called, we'd say graph A has a better way of showing the overall shape, and we would say that it is skewed left, which means there's kind of more data points over here than anywhere else. We say this is skewed left. All right, which graph is better at showing the gaps and clusters in data? Well, which one do you think would be better at showing gaps? The one that has a bunch of bins, or the ones that kind of says, oh, we have little small ones. Maybe there's some that aren't in this range. So we could say the ones that are, when we have more bins, we can see gaps and clusters better. So we'd say graph B. That would show gaps and clusters a little bit better. And then what percentage of the players have fewer than 850 songs? So we'd say add the bins that are 850 below, and since it's 850, I can go for this one over here, right? To the left of 850 songs, so we can say this one is 6, and this one is 4, and so it would be 10 out of our 50, which you could say is then 20 out of 100, which is 20%. So 20% of the songs, or 20% of the players have fewer than 850 songs. All right, so there you go. There is some quick notes and examples. We'll do example B here in a little bit.